Welcome students. Let's solve problem number 10.16. The cylindrical tube of a spray pump has a cross-sectional area of 8 cm square, one end of which has 40 fine holes, each of diameter 1 mm. If the liquid flows inside the tube is 1.5 meter per minute, what is the speed of ejection of the liquid through the holes? See, in this question, we have one cylindrical tube having opening end as a cross-sectional area A1 and closing end as a cross-sectional area A1. But here are some holes and holes are having area A2. They have mentioned there are 40 holes. So 40 holes are there having A2 is the cross-sectional area. Now the question is, the water is coming from this side and escaping from this side, but through these holes. Now we have to find the velocity of water passing through these holes. This is what the question is. For that, we are going to use continuity equation in which the product of velocity and the area is always constant. Now what velocity is this? That means the velocity of water at this opening end. Okay, so you can take, if you take the velocity of water at closing end, that is V2, and the area of the small hole, and if we take the product of these two, then also this product is a constant. This is what equation of continuity says. Now we will find the velocity of water coming from the small cross-sectional area denoted by A2. So in the solution, they have already given the cross-sectional area A1, that is A1 is equal to 8 centimeter square. Now we will convert it into SI unit, that is 8 into 10 raised to minus 2 meter square. So 8 into 10 raised to minus 4 meter square. We know that conversion, that is 1 centimeter is always 10 raised to minus 2 meter. So using that, if we will square this 1 centimeter square, then this must be 10 raised to minus 4 meter square. So we are using here that value. So finally we have A1, that is 8 into 10 raised to minus 4 meter square, and V2 is V1 is 1.5 meter per minute. Now the SI unit of velocity is meter per second, so we need to convert this quantity into meter per second. Okay, as we know, 1 minute is equal to 60 seconds. So we will substitute this conversion here and we will find 1.5 upon 60 meter per second is the unit of velocity V1, that is in SI unit. So 1.5 upon 60, if we solve this, we will get 0.25 into 10 raised to minus 1 meter per second. You can also write it as a 2.5 into 10 raised to minus 2 meter per second. This is the V1. Now we have V1, A1. Let's find A2, as A2 is the area of small hole having diameter 1 millimeter. So we also have to convert this 1 millimeter into meter, that is 10 raised to minus 3 meter. So A2 is equal to pi d2 by 4 pi d2 square by 4. Actually it is pi r square and r is d2 by 2. So we will take pi d2 square by 4. So we have a d2. We will substitute all these values, that pi is 3.14 and d2 is 10 raised to minus 3 meter square, as a d2 square is there, and upon 4 will be as it is. So after multiplying this we will get 0.785 into 10 raised to minus 6 meter square. This is the A2. So A2 finally we have 0.785 into 10 raised to minus 6 meter square. So this is the A2. Now we have to find V2. But before that we have to take care of all these 40 holes. So there are 40 number of holes. Okay. So we are not interested in water coming out from single hole, but we are interested in water coming out from 40 number of holes. So for that purpose, we will multiply it 40 times A2, 40 into 0.785 into 10 raised to minus 6 meter square, and the answer is 31.4 into 10 raised to minus 6 meter square. So this quantity is actually we are using in the equation of continuity. So all we have, that is A1, V1, A2, and we are going to find V2. So according to equation of continuity, according to equation of continuity, we have A1 V1 is equal to A2 V2. But remember, this A2 is now 40 times A2. This is what the definition. But as per the requirement, we are modifying this equation. So the finally we are going to find A1 V1 is equal to 40 times A2 into V2. Now we will take V2 on LHS and all these quantities on RHS and substitute those values. We will get, as we have A1 is equal to 8 into 10 raised to minus 4 meter square. V1 is equal to 2.5 into 10 raised to minus 2 meter per second upon 40 times A2. That 40 times A2 is 31 point. So we already have this value 40 times A2 here. So 31.4 into 10 raised to minus 6 meter square, and by substituting all these things, these these things will get cancelled. 10 raised to minus 4, 10 raised to minus 2 is a 10 raised to minus 6, and here also 10 raised to minus 6. So we will cancel this also. 8 into 2.5 upon 31.4, that is the V2 in meter per second, and you can solve it using log table or a simple mathematics calculation. You will get 0.6369 meter per second. By rounding off we will get 0.6. 637 meter per second. That is the V2, and V2 is the velocity of water coming out from these holes. Okay, and this is what the answer is, that they have asked what is the speed of ejection of liquid through the holes. So we got a V2, and this is our final answer. Thank you.